Welcome to Mastering Solutions. For this one, starting with a picture really helps to understand and keep everything straight. So if we draw this, we have a diverging mirror, so we'll put that over here. And we're told that we have this cyclist and he's 25 meters from the mirror. So here's our cyclist, and like we talked about, that is 25 meters away from the mirror. So that's 25 meters. And we are standing 1 meter away from the mirror. So we'll put us right here. And this is 1 meter. So now we need to figure out how far are we away from the image that is created of the cyclist. And so let's use the thin lens equation to figure out where the image is, right? And so 1 over f is equal to 1 over s prime plus 1 over the object distance. We're trying to solve for the image distance, so that will be 1 over s prime is equal to 1 over f minus, because we move this over, 1 over s. We know the focal length of the mirror is negative 80 centimeters because it's a diverging mirror. So 1 over s prime is equal to 1 over negative 0.8 meters. And then we're going to minus the object distance. And in this case, we're forming an image of the cyclist. So we'll use the 25 meters because the object to the mirror is the object distance, obviously. So 25 meters. So we have 1 divided by negative 0.8 minus 1 divided by 25 gives us negative 1.29 diopters. So you have negative 1.29 diopters. Now we need to figure out the image distance though. So we'll take the reciprocal of that. So divided by the answer gives us negative 0.78 meters. So we have negative 0.78 meters. That is the image distance, but we're not trying to solve for the image distance, right? So that is the image distance, but we're not trying to solve for the distance of the image. We're trying to figure out how far we are away from the image distance. So the negative means it's a virtual image. All diverging mirrors create virtual images, but the negative indicates that it's on this side of the lens. And so if we are 1 meter away from the mirror and the image that's created is another 0.78 meters away from the mirror of this virtual image that's created here, well, obviously, then we are 1.78 meters away from the image of the cyclist. So next we need to figure out the image height. And this one's a little bit more straightforward because we know the image height is equal to the object height, and then it's multiplied by the negative image distance divided by the object distance. Now I included the negative in this time. It comes from the equation. What this will tell us is if the image is upright or inverted. It doesn't really matter because we just want to know what the value of the height is, but I included it just to talk about the concept. And so the object height h is we have a 1.5 meter tall cyclist. We just found the image distance is the, let's see, the negative 0.78 meters. So we have a negative for the equation and then a negative 0.78 meters for s prime. That all is divided by the object distance, which we said is 25 meters. 25 meters there. So we have 1.5 meters, and then we're going to multiply that by a negative for the equation like we said, and then s prime is negative 0.78, and then that's divided by 25 meters for s. So we have 0.0468 meters. So if we move the decimal place 1, 2, we can round that to 4.7 centimeters. So since we kept the sign convention, the positive will tell us, just like we figured out, we have a virtual image and an upright image as well. So that makes sense because anytime you have a virtual image, it'll always be upright. And so here is the distance of how far we are away from the image, And then the height of the image is 4.7 centimeters. So it's obviously getting minification, or it's making it smaller image than the actual object.